Hello, my name is Jesse Chotiner, and this is for the Fluid Mechanics Summer 2025 final project where we're simulating a wind tunnel in ANSYS. I am doing part A of this project, and my two other group members, Kate and Connor, will be doing B and C respectively. So I will be doing part A. As you can see, I've already done it here and ran through it, but obviously we're going to go through it again. So we're going to go to Fluent Flow, and first thing we're going to do is, let me just rename this. And we're going to go into Design Modular, and we're going to create our wind tunnel. Alright, so to create our wind tunnel, the first time I did it, I utilized a different CAD software and just imported it in. But for this one, I'm going to create it here. So we're going to click on XY plane, and we're going to click on Sketch. And we're going to go to Sketch, and we're going to create three separate lines here. So we're going to go 1, 2, 3. Great. And then we're going to dimension each of these lines based off of the lengths and dimensions we've been given. So click on horizontal there. Oop, I gotta click the points. We'll have 1. We'll have 2. We'll have 3. So we're going to go into these dimensions and put in our values. So this is in meters, which is nice because we can just translate it to what we want. So first one's going to be 1.1176. Second one's going to be 1.2192. And the third one's going to be 1.5748. And obviously it shrinks it down here because we have smaller than our meters. Then what we'll have to do is we're going to do a constraint. Alright, so what we're going to do is we're going to go back to Sketch, and we're going to create a line that goes from here to here. And the way we want this, because we're going to want this in the middle, right? So we're going to go to Constraints, we're going to click midpoint midpoint of this whole line to there, and as you can see, we have it right in the middle, which is very nice. Alright, so next thing we're going to do is we're going to create lines that are going to represent our exits and inlets of our sections. So we're just going to create them over here. Hold on, give me a second. So we will create some lines separate over here. So we're going to go to Draw. We're going to create one. We're going to create one here. Create one here. And we're going to create one here. Then what we're going to do is we're going to do the same constraints that we did before, where we click midpoint, click this line, and there, and that puts that one there. Same thing here. Same thing here. And again, these represents our inlet, test section inlet, test section outlet, and then the outlet of the whole thing. Over here, same thing. And now what we'll do is we will dimension these four lines the way we want to. So we're going to click these over here, one over here, one over here, this one over here. And we will dimension these the ways we want to. So we're going to go down here to Sketch. Give me 1 second. Alright, so now we have our dimensions up here. This hid, so I had to redo it again. Or I had to just reset the window, but everything from what I did was what I did. So we're going to click this first one, and it's going to be 1.6256 meters. Second one is our test inlet, 0.60996. This is the same thing, 0.6096. And then this one is our outlet, 0.889. And these all actually translate to dimensions in inches pretty nicely. And the last thing we want to do is we're going to go back to Sketch, and we're just going to connect all these lines together to create our outer wall. Got that, got that. Nice. And then we're going to just delete all these lines we do not need. Alright, so we have our sketch here, which looks good. And next thing we want to do is make this a surface. So surface from sketch, we're going to click this, apply, generate, and as you can see, we have our surface. So now we're going to close out of here, and we're going to go to mesh, and we're going to create our mesh for our wind tunnel. So give that a second to open. Alright, so our mesh opened. First thing we're going to do is actually create our name sections. So we're going to do this, and we're going to do inlet. We're going to do this, and we're going to do create name, and we're going to do outlet. And then for our last one, we're going to do the top and the bottom. And because we don't have anything in the middle, we're just going to name these walls for now. And as you see, we go in here, we got all our names. So now we're going to mesh, and the first thing we're going to do, which is something I've come to like, is we're going to go to method, we're going to select our geometry, click apply, and we're going to do triangles. And triangles usually give you better results based on what you're doing. Same thing when you're doing 3D for tetrahedral. And we're going to click generate right now and see what that looks like. And as we can see, our triangles are very big, and we don't really want that. So we're going to go to our element size, and the default is 0.2. We're going to switch it to 0.01. Click that, click generate, and if we look, give it a second, as you can see, that makes our mesh much finer and more like how we want it. And we're going to just give some more details here. So we're going to go into mesh again, we're going to go into sizing, we're going to do body sizing, and what that means is we're just going to click this body here, click apply, and we're going to do element size, and we're going to do the same as before, 0.01, and that looks pretty good. Click generate, give that a second to do it. Alright, so that took a little bit to load, but as you can see, we have our mesh here, and we're going to, okay, we're going to exit out of mesh, we're going to click update, so that updates it in our workbench, and then we're going to exit out. Sorry, my computer is having a lot of issues. But we have our wind tunnel set up, we have our name selections, and we have our mesh. So we're going to now go into setup, and when we go into setup, we're going to do double precision and 4 solver processors, which is the maximum you can use for the student edition. And we will let that run up for a second. Alright, so we're in the setup here, and we're going to change our models and stuff to get where we need to. So we're going to be in turbulent here. The first thing we're going to do is turn on energy, because we can look at that. We're going to switch our model to, this would also work for turbulent, but I found the most success with Spalart, whatever it is. And we're going to click OK, and that's all going to be good there. And then we're going to go to materials, and the project asks us to do air as an ideal gas and viscous turbulent, which is why we switched the other thing. So we're going to go to air and click on this, and we're going to go to density, and we're just going to click ideal gas, and that's going to give us all our ideal gas properties. Density doesn't matter, and we're good to go. So we're going to click change and create, and that's going to give us what we want. Solid, that's fine. We're going to go to cell zone and check that that's good. Yep, looks good. And see, everything else is based off other things. So we go to boundary conditions, and we're going to put our inlet velocity. Now, the test, the project tells us to do a test velocity of 15 meters per second, which is for the test section. So our test section velocity has to be 15. So we have to do a little math using mass conservation. So we're going to use volumetric flow rate from the in to the out, and we were told to just use the height of it. So we're going to do 15 times 0.6096. then divided by 1.6256, and we get a velocity for the actual inlet of 5.625, and that should give us our 15 here, which was what we want. Click apply. It's going to look pretty good. Outlet pressure, make sure that is outlet pressure, and it is. We're going to go to walls, and these should be no slip condition, but not moving, stationary. Awesome. So that looks good. And we're going to go to reference values. We're going to click reference from inlet, just so it updates what we want to do. We're going to go to methods and check that. That all looks good. Controls, that's fine. We don't need to report any dimensions for part A. We will need to do the drag and other stuff later on, but again, that's what the other people are doing. Going to switch our residuals here to this because this is better results. So we click OK. And that's pretty much it for this. We can set up plots, but we can do that after testing is done. So we're going to click initialize, and that's all good. That's fine. And it froze. Give it a second. All right, so the initialization is done. We're going to go to run calculations. We're going to run for 1,000. Should converge before, but it might not because I made the residuals very high. But we're going to click calculate. We'll let that start up, and let's give it a second. All right, so as you can see here, our calculation is finally running, and it's probably going to go all the way because of the residuals, but we'll see what happens in a second. All right, so our calculations are done, and it ended before the 1,000. All right, so as we can see, the initial calculation is complete, and just to make sure we have what we're doing, we're going to go into contours. We'll do this in the results section after, but we're just going to go to contours, and we're going to select all our stuff. And all I want to check is our stack pressure. We click save and display. That looks really good. Pressure is higher here, lower here. And that's nice. So what we have to do in the setup tab is we have to get the variation of pressure, velocity, total pressure, diameter pressure along the center line, and get the vertical distribution of those same things at the center of the test section. So to do that, we're going to go to plots. We're going to go to XY plot, and we have our all our surfaces here and whatnot. And what we need to do is, so we need to create a center line along the entire surface. So to do that, we're going to go to new surface. We're going to do line rake, and we're going to name this center line. And what it's going to do is just do a center line across the entire thing. And how we do that is we divide by, or we're doing the length from one end to the other. If our origin is in the middle, we have to divide by the entire length. So we're going to get negative 1.9558 and 1.9558. And this depends on your coordinate system, but because ours is centered, this will be good. And 0 indicates that it's in the middle. So we're going to click create, and just for the vertical one, we're going to click a line rake again. We're going to do vertical line, and it's going to be the same process, but just for the y. So our x is going to see 0, 0 because that's in the middle. And this is going to give us, decent results in the test section. So we're going to do half of the test section diameter slash height, so 0.3048 for that one, and 0.3048 for that one. This should actually be negative. Alright, so we're going to click create, and that's going to give us vertical and center line. So first thing we'll do is we will check the center line for our parts. So we're going to go to pressure. And first we're going to do static pressure. So we're going to click center line. We're going to click order points. And we're going to name this, yeah, so this is pressure, which is just static pressure, which is actually what it's reading. So name it static pressure, center line, save and plot. And this is what we get for that, which is pretty solid for what we want here. Alright, and then what we're going to do is we're going to write the file so we can plot these later in Excel if we need to. So I'm going to go to this file. Well, actually, yeah. So we'll do this. Go here. We're going to do final case A pressure, centerline pressure. Just so we have that named. And I'll do that for the other ones. I won't show that here because it's the same process. But next thing we're going to do is check our let's close that actually and then create a new one. And we'll do velocity. Actually, I should name the centerline velocity. And we got that. So we're going to click on pressure, velocity, magnitude, back on centerline. And we have this, which shows our velocity is increasing at the test section, close to 15. That could be based off the mesh or whatnot, but it definitely increases and goes down. So we have that. And then we're going to click close. Then we're going to go back to XY plot. And we're going to do centerline total pressure. And this is going to give us a wonky number, I believe. So we're going to go to total pressure centerline. And sweet. And the reason this is doing this is because for some reason the Y puts it very, very close to these pressures. So what we're going to do to fix that is we're going to click on this and we're going to get rid of auto range and we're going to do minimum and maximum that we set. So this is like 57.4. So let's do 55 to 60. Click apply. And as you can see, our total pressure remains constant because, pressure along the thing will be equal, obviously depending on the static dynamic pressure, and that's based off Bernoulli's. So that's good. And we will save and plot that for later. And then we'll go to this and we'll do our final one, which is our dynamic pressure, which is based off our velocity. So dynamic pressure, center line. And as you can see, we start lower, go up more, and back to the bottom. And that makes sense because it's a function of velocity, and it should be opposite of our, well, not opposite, but should be the same with our velocity distribution. So that's all good for those. And next thing we're going to do is create our 3 plots for the vertical distribution for the velocity, dynamic pressure, and total pressure in the center of the test section, which is our vertical line here, which we did, which is again at the center. So what we're going to have to do is switch this to position on Y, and because our plot direction is now in the Y, we'll do it this way, so it will look a little nicer for us to look at. And yep, that looks good. So first thing we're going to do is pressure stat. We don't need static pressure actually, so we'll start with velocity. We'll click this, and this looks weird. And the reason that is because I think I ordered points. If I do this, yeah. So this gives us a nice distribution of our, oops. And again, this is just our velocity at that center test section. And as you can see, it's closer to ends in here. And that looks good. So we're going to name that vertical velocity. Save and plot. Nice. We're going to create a new plot. Sorry about that. We're going to create a new plot. 1, 0, node values position. And this will be for the vertical dynamic pressure. And that's all this stuff right here. Center line. There we go. Okay, so this isn't right. I meant to click vertical line because I was like, wait a minute, this looks really far off. So if we click this, Nice. We get the same thing as our vertical, as our velocity in a sense. It's a function of that. So that looks good. We're going to click close, and we're going to go to our final one, which is total pressure along the vertical line. We'll go vertical, total pressure, and we'll go to total here, and we'll go to vertical line. Switch this to Y, so it looks nicer. 1, 1, 1, 0. Save and plot, and yeah, this is looking pretty good. And I just realized this is our static pressure, not our total pressure. So it's going to look a little different again because static is a constant there. So we're going to go to total pressure and click that. And we get a nicer distribution along it. Because again, that's a function of all the pressures combined. So that is our total pressure. So if we want to go back, just because that was a little all over the place, this is our static pressure for center line. Save and plot that. You can see right there. Center line for velocity, right there. Center line total pressure, right there. Center line dynamic pressure, right there. Vertical velocity, dynamic pressure for the vertical, and then total pressure for the vertical. And I'm going to export these really quick, so give me 1 second. Okay, so all of those have been exported to Excel, and we're going to click outside of the setup, and we're going to go into our results, and now we're going to show our contours for all these parameters that we've looked at, and the streamline patterns of the wind tunnel itself. Alright, so we're going to go into results, open that up, and we're just going to show a few contours of our thing. Go here. And what we're going to do is we're going to go up here to contour, and our first thing is going to be our static pressure. So we're going to go all domains. We will do symmetry 1, and we're going to go to pressure. Click on 110. Click apply. And as you can see, this is our static pressure, and I mean it's our regular pressure, but same idea as we saw before in the setup. Low pressure, high pressure, or the other way, sorry, high pressure, low pressure as we go along. And that looks pretty good. And then we're going to go to contour. We're going to go to velocity. That already exists. So let's do velocity contour. Now we have a velocity contour. We're going to turn that off. Go back to symmetry, 110, and click on velocity. I'm going to click apply. And as we can see, it's basically the opposite of our pressure. Low velocity here, high velocity here along the test section, and this is the vena contractor effect here. That's why the velocity is so high. But that also looks pretty good. And I just realized you cannot find dynamic pressure here, so we're going to have to go back in the setup, and I'll give you the total pressure and dynamic pressure that we found. Actually, before we do that, we do have to show the streamline patterns. So we're just really quick going to show streamline 1. Do that. We're going to click 3D streamlines, all domains, equally spaced. We'll do around 250 for velocity and click apply. Ooh. Second. Alright, that's my fault. I forgot to click here. So I'm going to click symmetry 1, and we're going to click apply. And as you can see, we can see our velocity streamlines. They're very nice. Starting low here, getting higher here, and as we go along. So now I'm going to go back in the setup to show the total pressure and dynamic pressure. Alright, so our setup opened again. We're going to go into contours, and we're going to go to pressure. We're going to go to, that's fine. We're going to go to dynamic pressure. Name this dynamic pressure. And we're going to click ease. Save and display. And this is our dynamic pressure, which makes sense. Again, it is a function of velocity. So it should be lower here. Should be a little higher over here. And then we're going to click close. We're going to click contour again. We're going to make a new one for total pressure. And this should be pretty constant across this whole section, if I'm correct. Total pressure, boom, 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 boom. Perfect. So yeah, you see total pressure remains the same along its boundaries and stuff. And that's pretty much it. So I know this is a little longer. I was having a lot of issues, and it was because Cisco wasn't connected, so I wasn't on the VPN. But we went through the pressure, velocity, total pressure, dynamic pressure contours, along with them along the center line, and the vertical distribution, and the streamlines of it for part A, and utilizing the test section velocity with the different inlet velocity. And my other two members will be doing part B and part C. And yeah, thank you for your time.